Hi everybody, in this video tutorial we are going to see how to simulate steady transonic turbulent flow past ONERA M6 fin. First step in HiFUN to setting up the problem is to set the working directory. Go to menu bar, click on tools, click on options button. Click on tool settings. First option is project repository. Click on browse, click on HiFUN, test case, ONERA. Click on open. The data related to this project will be stored in this working directory. Second option is opening here. If you want to run it in a parallel machine, we have to give machine file path here. For this test case, let's run it in a local machine. Keep it other options are default. Click on apply. Close. It will pop up the window saying that no input file given for opening here. Hence solver can be run on local machine only. Click on close button. Go to menu bar, click on file. It will show submenu. Click on new project. Let's give project name as ONERA M6 win. ONERA M6 win. Second option is select.msh file. HiFUN will read grid in .msh file format. Let's click on browse button. HiFUN test case ONERA. Select ONERA M6.msh file. Click on open. Let's invoke zip output option to zip pre-processing data. Click on next button. This page corresponds to scale. Grid properties was in mm. Let's convert grid properties millimeter to meter. Let's give 0.001. Click on next button. This page corresponds to boundary condition. The left list shows the boundary zones available in the grid. The right list shows boundary condition available in the HiFUN solver. To know about boundary conditions, please refer to HiFUN user manual. Farfel-Riemann is Farfel-Riemann. Click on apply. Wall ring is wall boundary condition. Symmetry is symmetry boundary condition. Interior is interior boundary condition. Click on apply. Click on next button. This page corresponds to volume zone. This grid does not contain porous zone or rotating zone. Let's click on next button. Number of subdomains. This page corresponds to number of subdomains. Number of subdomains is nothing but number of MP processes used to execute HiFUN. Let's execute HiFUN using 4 MP processes. Let's give 4. Click on next button. This page corresponds to check grid. Invoke the check grid to test grid sanity. Click on finish button. It will ask to continue for the pre-processing data. Click on yes button. HiFUN has 2 steps. First one is pre-processing step, second one is solver. In the pre-processing step, it will read number of points, number of cells, number of phases information from grid and store it in HiFUN format. To complete the pre-processing steps, it will take few minutes. Once completed the pre-processing step, create a new run. For this, go to menu bar, click on run, click on new. This test case is steady simulation. Click on steady simulation. This will open the basic options wizard. First option is name of run. Let's give alpha 3.06. Let's continue with the same number of subdomains. Let's give 4. Next option is nature of flow. HiFUN has 3 options: invisible, laminar, turbulent. This test case is turbulent flow analysis. Select turbulent flow. Let's keep initialization procedure as general. Click on OK button. It will open Advanced Options wizard. Left side tree you can see solver setup, flow parameters, solver run options, boundary conditions. Let's start with the solver setup. First option is flow. Click on flow. First one is flow type. HiFUN has three options: external side slip, internal, external room. This test case is external flow analysis. Let's select external side slip. Next option is turbulence model. HiFUN has three turbulence model: Spallard Tolmaras, K omega SST, K omega TNT. Let's select Spallard Tolmaras for this test case. Next option is low Reynolds number variant. Low Reynolds number variant invoked for low Reynolds number flows. Next option is compressibility correction. Compressibility correction invoked for base flows. Let's not invoke these two options for this test case. Click on apply. Next option is preconditional. Preconditional will be invoked for low speed flows. Let's not invoke for this test case. Next option is spatial discretization. First one is scheme for invasive flux calculation. HiFUN has 7 schemes. We are frequently using 3 schemes: rho, HLLC, Vernier. Rho scheme will be used for subsonic and transonic flows. HLLC scheme will be used for supersonic and hypersonic flows. For Euler simulations, we are using Vernier scheme. This test case is transonic flow. Let's select rho scheme. HiFUN is using Green-Cross scheme for viscous flux calculation. Let's select second order accuracy for this test case. For gradient calculation, HiFUN is using primitive reconstruction. Invoke limiter option. Let's use default value as a limit control parameter. Next option is robustness fix. Robustness fix is generally invoked for the simulations involving high supersonic flows or problems having large grid-induced stiffness. Let's not invoke robustness fix for this test case. Click on apply button. Next option is temporal discretization. Implicit time integration procedure used for this test case. Next option is number of sweeps. Let's use default value. Let's use 0.8 as an under relaxation parameter and invoke implicit boundary option. Click on apply. Next option is flow parameters. Click on freestream condition. First one is flow direction. In this grid, freestream direction is X and normal direction is Y and cross flow direction is Z. Let's select X, Y, Z. Next one is Mach number. This test case Mach number is 0.84. Next option is angle of attack. For this test case, angle of attack is 3.06 degrees. Side slip angle for this test case is 0. Pressure value is 56913.16. Temperature is 273.15 Kelvin. Dynamic viscosity is 1.7238 e power minus 5. Thermal conductivity is 0.02408. Let's keep same value for modified turbulent viscosity. Click on apply button. Next option is reference value. Characteristics area is 1. Reference moment arm is 1 for this test case. For this test case, moment reference point is 0. Let's give X, Y, Z moment reference points are 0. Reference pressure is freestream pressure 56913.16. Click on apply. Next option is solver run options. Click on Solution Convergence. First one is Solver Start option. HiFUN has three options: freestream, int restart, restart. For freestream option, solution will be initialized from freestream conditions. Second one is int restart. For int restart, solution will be initialized from available results and start from first iteration. Last one is restart. Using restart option, solution will be initialized from available results and continue from last iteration. Let's initialize solution from freestream condition for this test case. Let's select freestream. Next option is residue for convergence. Let's keep default value as e power minus 10. Click on apply button. Next one is choose time step. Time step. Let's use global for this test case. Next option is number of iterations and CFL ranking. Click on set. 1 to 500. Let's give 1. Add 500 to 1000. Let's give 3. Add 1000 to 1500. Let's give 5. Add 1500 to 2000. Let's give 10. The last end iteration consider as maximum iteration for this analysis. Click on OK button. Invoke free CFL. Let's keep maximum permitted CFL values default value. Click on apply. Next one is parallel input output. Let's keep read option is parallel read. Let's keep frequency for storing restart file is 100. Each 100 iterations, restart files will be updated. Next option is volume data. First one is storage frequency. Let's give 10,000. Next option is storage instances. Click on add button. If we want to store any intermediate volume data, we have to give instances here. For this test case, let's not store any intermediate volume data. Click on OK button. Next option is volume variables. Click on select. The selected volume variables will be stored in post-processing data. Click on OK button. Next option is boundary data. Let's keep storage frequency as 10,000. Next option is storage instances. Let's not store any intermediate boundary data. Next one, boundary variables. Click on select. Selected boundary variables will be stored in boundary data for post-processing. Click on OK button. Next one is integrated variables. Click on select. Click on select all. All the force and moment coefficients file will be stored in integrated variables. Click on OK button. Invoke zip solution data to zip all the solution files. Click on apply button. Next option is boundary condition. Under boundary conditions, we can see fluid, Fairfield Riemann, interior boundary conditions, symmetry boundary conditions, and wall boundary conditions. If you click on symmetry boundary condition, it will display that no additional parameters are required for this boundary. But if you click on wall boundary condition, it will show that wall velocity type and wall thermal condition. First one is wall velocity type. HiFUN has two wall velocity type, translational and rotational. For this test case, let's use translational wall. Next option is wall thermal condition. HiFUN has adiabatic wall and isothermal wall. Let's use adiabatic wall for this test case. Let's select adiabatic wall. Click on apply and save and close button. Once completed all the inputs, go to project name, click on the arrow mark, It will show the runs created under this project. Let's click on the run name. To start the solver, go to menu bar, click on solver, click on execute button. It will read all the freestream condition and boundary condition information and start the iteration. To stop the run, go to menu bar, click on solver, click on halt button. It will ask to halt the solver execution. Click on yes button. Once program is halted, it will save the solutions data for last iteration. To copy and edit the run, go to run name, right click on the run, copy. Let's create new run angle of attack 4. Let's select properties, click on OK button. It will copy the new run. Right click on alpha 4, edit, advanced options. Click on freestream condition. Let's give angle of attack 4 degrees. Click on apply button. Click on save and close. To export boundary data and volume data, click on the run, go to menu bar, click on export, click on boundary data. You can export wall boundary and fairfield boundary data. Next option is volume data. HiFUN has 3 formats: VTK format, CGNS format, TechPlot format. Next option is wall coefficients. Click on wall coefficients. Click on total. It will show force and moment coefficients in body axis system. If you want to convert body axis to wind axis, right click on total button, convert body to wind axis. Click on close button, click on close. To close the projects, go to the menu bar, click on file, click on close. It will close the project.